I'm Rajesh Kumar Patel, PGD Chemistry, JNV, Ratiwar, Bhopal. Welcome you all in PM E-Vidya channel. Dear friends, today I am here for class 9 Science. Before starting our lecture, dear friends, I want to show you some pictures. Dear friends, can you see these pictures? Yes, you can see. Can you tell me the name of these pictures? What are they? Yes, you are right. First one is milk, the second one is sugar, and the third one is chalk. Dear friends, now let's do some interesting activity. What you have to do, take 3 glasses, add some water and add these samples in that water and dissolve. After dissolving, what do you observe? Which kind of nature you are observing? And after observing, can anyone guess the nature of the solution? How they are appearing? What is the color? What is the nature of these samples? Okay, so dear friends, today we'll discuss first one about the colloidal solution. I have taken those examples to show you the different types of solutions. Out of those solutions, we are going to study a colloidal solution. So let's have a definition. A colloidal solution is a heterogeneous solution in which dispersed phase is dispersed in dispersion medium. Here, what is dispersed phase? This is nothing else, just solute. And the dispersion medium, this is nothing else, just the solvent. So as we have already studied, when we dissolve solute in solvent, the result is solution, like that. When dispersed phase is dispersed in dispersion medium, the result is called colloid. So here one question arises, how can we differentiate the colloidal solution from true solution? So here friends, let's see this picture. This is, you have already seen this is nothing else, just the milk. But here, why I have taken the example of milk? Because milk is a colloidal solution. Some other examples are there. For example, milk, you all know, egg albumin in water, starch in water. You have seen starch in, where you have seen starch? Yes, you have seen it in potato. When you crush the potato, the white powder you obtain, or the white solution you obtain, that is the colloidal solution. Okay, so after knowing the definition of solution, or after knowing some examples of colloidal solution, let's see some properties of colloidal solutions. The first property, this one is the nature. Here, nature means how it appears. The mixture appears to be homogeneous, but actually it is heterogeneous in nature. Why it is happening, dear friends? Why I am saying this one is appearing homogeneous, but actually it is heterogeneous? So dear students, since the particles of colloidal solution, it is very small, so it seems to be homogeneous. You can't see the particles separately, so it seems to be homogeneous, but actually we will study some more properties which will prove the nature of the colloidal solution. This is heterogeneous. The second property, this is visibility. Visibility means, can we see the particles of colloidal solution? For example, if you dissolve chalk in water, you can clearly see the particles of chalk. Okay, so the particles are visible. But in colloidal solution, the particles are not visible. We can't see the particles with a naked eyes. So here, the particles are so small that they cannot be seen by naked eyes, but they can be seen by using microscope. Okay, Now, third property, it is filtrability. Filtrability means we cannot filter the colloidal solution by ordinary filter paper, by cloth or by any simple means. You have already experienced we can't filter milk from cloth or the filter which you use in tea. Okay, we can't filter the milk. So that's why the solute particles cannot be separated by filtration. Got it? Next property, this is stability. Stability means you have seen muddy water in rainy season. You have seen muddy water. If you take some sample of muddy water in a glass and leave it undisturbed for 10 to 15 minutes, sufficient. After that time, 10 to 15 minutes, you will see the particles of the mud is settling down. It means the solution is not stable. It was temporary solution. Got it? But in case of colloid, the colloidal particles, they do not settle down. They are stable. For example, milk. If you keep that milk sample for 1, 2, 3 hours, the milk will not settle down. The particles present in milk will not settle down. Got it? That is the stability. After stability, the fifth point is Tyndall effect. What is Tyndall effect? So friends, the colloidal particles scatter a beam of light passing through it, and the path of light is visible in the solution. This effect is called Tyndall effect. It means, let's have an example. We'll do some activity to understand this Tyndall effect clearly. Okay, let's do. Here, take a torch. You all know where can we get a torch. Take torch and two different solutions. Solution in first bottle and solution in second bottle. That is colloid. Torch, it is acting as light source, and when we incident the light or when we pass the light from the torch in these two samples, these two solutions, in first case, in solution, the path of the light, it is not visible. Got it? This path is not visible. But if we pass this light furthermore, then the path of the light, it will become visible. And in third case, suspension, we are taking suspension. So here friends, we have three different solutions. First one is two solution, which is commonly known as solution, colloid, and the third one is suspension. In two solution, we can't see the path of light, but in colloid, we can see the path of light, but particles cannot be seen. But in suspension, we can see the path of light as well as the particles very clearly. So this is the basic difference, or by this Tyndall effect, we can differentiate true solution, colloid and suspension. After this Tyndall effect, where can we see some more examples of Tyndall effect? So dear friends, we can see in our daily life also. So very simple, we have seen, let's take some example in dark room. Dark room means in your house before sunrise. As the sun is getting rise, at that time, you see in our home there is a window. In everyone's home there are windows, but we'll see one window, and if you open that window, the light will come inside the room, and the path of light, you can see the path of light, this one is becoming visible. Why it is becoming visible? Because in the room, the dust particles are present. We are not able to see the dust particle at normal condition. But as the light enters in the room, the path of light becomes visible. So this visibility is due to the scattering of light by the dust particles. So this is Tyndall effect. Take Another example, that example in dense forest. Here in dense forest, you can see this is the picture of the forest. You can imagine this is the evening time, or you can say this is the sunrise time, or it's afternoon time also. But better example of this Tyndall effect can be observed in a better way in sunrise time. In sunrise time, the intensity of light is not so much. So that's why the leaves, the stems, or some obstructions in the path of light. So because of that, those obstructions, the light is coming, but the intensity of light is very poor. So the path of light, it becomes visible. Why does it is becoming visible? So dear friends, this is due to the mist. Mist means what? Mist means the water droplets present in air. So these water droplets, they scatter the beam of light. They scatter the sunlight. That's why this scene is seen in forest. After this, take one more example. Okay, and tell me what that example is. You search and tell me. Okay. Last property. This one is Brownian motion. What is Brownian motion? A very simple manner. The colloidal particles move in zigzag path in solution. Got it? They move in a zigzag path. For example, see, this is a beaker. I have filled water in this beaker and I have dissolved some solute. Here I am representing the solute particles by some dots to explain the Brownian motion very clearly. Here, my friends, you see this dark circle, okay, red circle. You see this dark red particle will move in this solution, but in random motion. How? So let's see where this particle is moving here. That the path is not fixed. The particle is moving in any direction. Why these particles are moving? Because as this particle is moving in a straight line, another particle comes into the path. So it collides with the particle, it strikes with the particle, and due to the collision, the path of the particle changes. The path will change, but in that path again another particle will come. So due to the random movement or the random collision of the particles, the movement of particle is zigzag. Got it? Okay. So now we have understood Brownian motion. So let's revise the properties of colloidal solution. Just revise. First, nature, heterogeneous. Second one, visibility. Visibility means cannot be seen by naked eyes, but can be seen by microscope. Remember this thing. Third property, filterability, cannot be filtered. Stability, this one is stable. Tyndall effect, shows Tyndall effect. And Brownian motion, shows Brownian motion. Okay friends, that's all for today's session. Here, I hope you have learned the colloidal solution and the properties of colloidal solution. So let's try to find out some more examples of colloidal solutions. Okay, thank you.